Hello students. All right, so this is week 4 materials. We're going to talk about systems of equations and also linear inequalities, right? How to graph them. Okay, so let's start with systems of equation. And so basically systems of equation is when you have two linear equations with two variables in our cases, right? You can have multiple more than two variables involved for a system of linear equation. But in our case, it's only two. And so what we're really talking about is two linear equation in a coordinate plane. And let's look at the different scenario when you have two linear equation, right? Any type of two linear equations. The first one, you will have intersecting lines. Intersecting lines, right? That's the most popular one. That's when you have, okay, well, I apologize about my drawing, but let me, yeah, so I have my coordinate plane, right? The X and Y axis. So we're gonna pretend that those are straight, X and Y. And then we have two lines. So let's say this is might be Y equal mx plus b, right? So that's our first linear equation, and maybe another one. We are putting in green, right? So that's maybe the we're going to put it as a standard form: ax plus by equal to c, right? So you have two linear equations, and you notice that they intersect at a particular point, okay? And that point is actually your solution to the systems of equation, right? So our system of equation would be two linear equation, and the point x and y, whatever the value would be for x and y, when you plug them in into your equations, linear equation, then if I plug in whatever the value is for x and y, it has to be equal to -5, and also when you plug it in, it has to be equal to -3. So it satisfies the two equations, right? So that's intersecting line. You only have one solution. So there's only one solution for this type. Okay. Then the second, so this is your first scenario. The second scenario is, so you have your coordinate plane, right? Line number 1. I'm just going to call it line number 1, right? L1, and then L2. Right? And those are parallel lines. So this is my second scenario, so parallel lines, right? You notice that there is no intersection whatsoever. They never touch each other, so they have no relationship between each other. So in this case, there is no solution. There is no solution. Okay? So that's the second scenario. The third and last one will be, yeah, I think sometimes they call it coinciding lines. Some just or overlapping lines, depending on the textbook. So I'm going to put coinciding lines, or sometimes they say overlapping lines. Okay, so let me put the example right here, or at least the graphical one, and then in blue we'll have this line, right? That's L1, and then right on top of it I have, and let me put the maybe a thicker, yeah. right on top of it, you have the other line, which is L2. Okay? All right, so you're going to tell me, okay, well, they're pretty much the same lines. Exactly. They are equivalent. And what they share is infinitely many X and Y coordinate plane, right? So they share all those points, okay? So not just one point that is a solution, it's everything on the same line. Those are all the solution, right? So X, yeah, so I can put X and Y, right? So they have infinitely many solution for X and Y, okay? So you have a solution will be many solution for, and you have to specify for X, Y, for the coordinate X, Y. Okay, so those are the three situations that you might have, right? So we're going to look at techniques or methods on how to find that one solution, parallel lines, and coinciding lines. All right, so the one method would be to graph, and then you will be able to, so you know how to graph linear equation, then the challenge would be to find the intersecting point, right? So if you have two parallel lines, you know, when you graph them, you should be able to see that. Coinciding lines, same thing. Okay, now let's look at the next set of problems where you have to decide whether the ordered pair, right? The ordered pair would be the XY coordinate, right? The intersecting point is a solution of the given system. So in this case here, I want to know if the coordinate point 4, -2, or the ordered pair 4, -2 will satisfy this systems of equation, right? All I have to do is plug them in, and see if it's going to be equal to -6 and also -2, right? So you have to satisfy both. So let's start with the first one. So you have 4 for X, right? So this is X, this is Y. So you have 4 plus -2, and it has to be equal to -6. And we know that 4 plus -2 is not -6. So we do not need to go to this next one, because only one of them needs to be false, or a false statement, to disqualify 4, -2 to be the solution. So therefore 4, -2 is not a solution to the system, to the given system, right? And that's it. That's how you kind of answer this question. So here, I'm not going to do solve by graphing method, because basically we've done that last week, where you need to graph, you know, 2x plus y equal to -4 and 5x minus y equal to -37. You graph them, and then you find the solution, right? So anyway, so let's move on to the methods. Okay, so the first method that we're going to look at is the substitution method. Okay, so the substitution method is as follows. All you have to do is take one of the equation, right, any of those two equations in the system, and solve for one of the variable, right? And usually you will solve for a variable that is by itself. Like, so for example, x. So you will take the first equation because x is by itself. Okay? You will not take the second one. And the reason why you will not take, I mean, you could, but the reason why you wouldn't take the second one and solve for x or y is because if you solve for x and y, you're gonna have some fractional terms, and you don't want to go through the substitution method using fractions, right? It's going to add some additional steps. So it's always best to use one that has just the x and the y variable. Okay, moving on. So here we need to solve equation 1 for x. Okay, so we're gonna have, so I need to move the plus 8y to the right side, so I'm gonna have x equal to 57 minus 8y, right? So that's my first step. Once I have done that, I'm gonna use this expression 57 minus 8y and plug it in into the second equation. So you're going to plug in the expression of what x is, and then plug it in into really right here where x is. Okay, so that's exactly what we're going to do. We want to substitute (57 minus 8y) into the variable x of the second or other equation. Okay, so now it becomes -2, right, times x, which is 57 minus, well, 57 minus 8y plus 7y equal to 47. Okay, so now you notice that now only have one variable, right, in that equation. Once I do that, now I can focus on solving for y. So I can solve for y now. Okay, so it's going to be -2 times 57, that's -114 plus 16y, right? Because -2 times -8y is positive 16y, plus 7y equal to 47. Okay, so we combine like terms. That -114 is going to be moved to the right side, and we're going to have 16y plus 7y equal to 47 plus 114. Then we have (23y) equal to 161. I divide by 23, and you get, let me check, 161 divided by 23 is 7. Okay, so y is equal to 7. But we're not done because we don't know what x is equal to, right? Let's not forget, every time we're trying to solve for for a system, you have two variables. In this case, it's going to be x and y, and that x and y really represent the intersection of the two lines, right? So your solution has to be expressed as an ordered pair. Okay, so now we're not done. We need to solve for x now. So if you want, you can use this if you want to, or you can use one of the equation, one of those two, doesn't really matter. So let's say you have x plus 8 times y, 7 equal to 57. So that means x plus 56 is equal to 57, which means that x is equal to 1. And we have the value of x, and we have the value of y, and the solution is the order pair 1, 7, right? And you have it right here. And that's it. That's how you solve a system using the substitution method. All right, so let's do another one. It's something that you wouldn't want to use. You wouldn't want to use a substitution here. So let me kind of take a look at, if I were to rearrange that. Obviously, when you have a substitution method, yeah, so you will try to avoid using substitution method for this one. You could do it, but the reason why is because you have the -7 here for x and the -5, and then for y term you have positive 3y and 7, right? So most likely you're gonna have some rational expression or rational term, right? And you don't want that. Okay, even though this one might work out if you take the first one divided by 7, then but you have some extra step here. But you will try to avoid. What you want is a clean variable that is by itself, just like we did previously in this one, for example, right? Let me just look for another one. This one is perfect because it's already set to y, right? So you see that y equal to 4x plus 3, you're all set. All you have to do is plug in 4x plus 3 into y and you start the process. Same thing for number 9. Okay, number 9. And then if it's not in that format, in those format here that I just showed, then you move on to the elimination method. That would be the best way. Okay, so let's do another one. Let's do this one, for example. Right? So here we want to, plug in. Actually, I want to use this one. It might be interesting. Okay, so let's, not really. But anyway, let's do this one. Okay, so here x is equal to y plus 2. So we want to plug in y plus 2 into x. So it's going to be y. Oops. Use black ink. So it's going to be y plus 2 minus 2y equal to 5. Right? So I'll replace the x here with y plus 2. And now everything is in y terms. So it's going to be y. So it's going to be y minus 2y equal to 5 minus 2, right? So the positive 2 becomes -2 on the right side. And now we get negative y. Oops, sorry. Negative 1y or negative y equal to positive 3. Obviously, we don't want the negative for the y because we saw it for positive y. So y is equal to, so we divide by -1 if you want. Area y equal to -3. That's the value for y. And then now you solve for x. So now you have x equal to -3 plus 2. That's the value of y. And x equal to -1. So my answer should be -1, -3. The ordered pair, the intersection point. All right. So now let's look at the elimination method, or also called as the addition method, right? Elimination or addition method, those are synonymous. Now, how does it work? Well, we're going to look at this simple problem here. It's perfect for the for this concept. So basically, the elimination method is when you're adding the two equation in the system vertically, right? So I need to add the two equation vertically. But before I start, if you're having if you want to use the addition method or elimination method, you have to have the two equation in standard form, meaning that it has to be ax plus by equal to c, and the second one would be dx plus ey equal to f, for example, right? It has to be in that format. If it's not in that format, right, so the x term is lined up with the x term, the y term is lined up with the y term, and the constant is lined up with the constant term, right? If it's not in that format, then you need to rearrange it so it looks like two standard form, okay? So that's what we have here, x plus y equal to 12, x minus y equal to -6. They're both in standard form. All right, so now, so what you want to do for the elimination method is to add the two equation vertically, But what's the purpose? In order to cancel out or to eliminate one of the variable, right? So if I'm looking at, so I'm just going to rewrite this, x plus y equal to 12 and x minus y equal to -6. All right, so if I'm adding vertically, right, I get x plus x, 2x, and then here, fortunately, well, for our purpose, the y term cancel out because positive y plus negative y is equal to 0, right? It cancels out, okay? And that's exactly what we want. And then the constant term 12 minus 6 is 6. That's exactly what we want because we just want a term. We want an equation with one of the variable only. And that's what we got. 2x equal to 6. Now I can solve for x and x equal to 3. And if you have the value of one of the variable, then you can solve for the other variable. And you can take any of the two equations. I'm going to take the first one, x plus y equal to 12. And then you have 3 plus y equal to 12, meaning that y is equal to 9. Okay? So, my answer would be 3, 9. Okay, which is right. All right. That was the easy part because now, because when you add vertically, automatically we had the y variable canceling out, right? That was an easy one. Now let's look at when you add the two equation vertically, then nothing cancels out. So how do we approach it, right? So here, let me rewrite this: x minus 7y equal to 19, and then x negative 7x minus 8y equal to 38. Okay? If I'm adding vertically, right, what happened? Here I get negative 6, and here we get negative 15y. Nothing cancels out, nothing ends up to be 0. So we have a problem, right? Okay, how can we solve this problem? Well, if you have an equation, right, you can rewrite it, that equation, or you can rewrite an equivalent equation. So for example, if I say x equal to 4, right? That's an equation, it's just x equal to 4. But if I put 2x equal to 8, these two equations are equivalent. How do I know? Well, if I multiply this by 2, what happened? I get 2x equal to 8, right? Another one, if I put 10x equal to 40, again, this equation and this one are also equivalent, are the same. Because if I multiply the first one by 10, I get 10x equal to 40. Okay? And I know these two are equivalent. So I can do the same thing here with the system of equation. And I'll say, like, okay, so what's my thought process? Well, I need to add these two equations so that one of those variables will cancel out. So let's say I'm focusing on the x term, right? So I'm focusing on the x term here. And obviously, I cannot add these two and make it equal to 0. But I can multiply this equation, the first equation, by a value where the value in front of the x will be the opposite of negative 7. So I need this to be what? Positive 7 here. So therefore, all I have to do is multiply the whole equation by 7, make it equivalent, and then I can add the two equations vertically. Okay? So that's the idea. You choose the variable that you want to cancel out. Here it was easy because you had x by itself, and here all you have to do is kind of find what is the value that you want that is opposite to this, right? So that's all you had to do. So in this case, we want 7 to be multiplied by this whole equation and find that equivalent equation. Okay, so it's going to be 7x minus 49y equal to 19 times 7. Let me see what that is. 19 times 7. That's 133. And then the second equation stays the same. Negative 7x minus 8y equal to 38. Okay, so now you can add vertically. The x term is equal to 0. Now here I have what? Negative 57y equal to 133 plus 38. That's 171. All right, let me remove this here. And 171 divided by 57 is negative 3. So you divide this by negative 57. And that gives me y equal to negative 3. So once I have the value of one of the variables, it's easy. I'll solve for the other one by using any of the two equations. I'm going to take the first one, x minus 7y, or negative 3 here, equal to 19. That's x plus 21 equal to 19. So x equal to negative 21 plus 19, that's x equal to negative 2. Okay, so my answer is going to be x equal to negative 2 and y equal to negative 3. So that's the one here. Okay, so that's that. So that was the elimination method, right? Now let's look at another one. This one is a good example, right? So let me rewrite it right here. 7x plus 8y equal to 51, and then 3x plus 5y equals 25. Okay, so here if we add vertically, nothing, right? It's not going to cancel out. 8y and 5y, it add vertically, it doesn't cancel out. Okay, now we have to find equivalent equation where when you add vertically, it's going to cancel out. Also, all right, so all we have to do here, if you're in this situation, so here 3 and 7, they're not multiple of each other, right? So they're pretty much prime. Same thing with 5 and 8, right? They're not factors of each other. So it's kind of difficult to, it might not be that difficult. All you have to do here is to use their coefficient, which is the 3 and the 7, if you want to cancel out the x term, right? You take their, and you can do it with any of them also. You take their coefficient and you kind of cross multiply, right? So the first one you're going to multiply by 3, and the bottom one you're going to multiply by 7, right? And we know that when we're going to multiply across, the x term is going to be 3 times 7, 21, and 7 times 3, 21. But here we have a problem, because when we multiply 3 times 7 and 7 times 3, they are positive 21. We need that for these two terms to be what? Opposite. So one of the multiple here, 307, has to be negative, right? So here we want to make sure that one of them is negative. It doesn't really matter which one. It could be the negative 7 or it could be negative 3. Doesn't matter. One of them has to be negative. Okay, so now we've established that. So if you wanted to get rid of the y term first, then you will multiply this one by 5 and the bottom one by 8, and one of them again will have to be negative. It could be the negative 5 and so on. Okay, all right, so let's multiply across. So it's 21x plus 24y equal to 155, and then you have negative 21x, negative 35y equal to 25 times 7, or negative 7, That's negative 175. Okay? Okay, so blah, 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 blah. So this cancels out. And then here I have the 24 minus 35. That's negative 11y equal to negative 20. So it looks like maybe oh, hold on, 3 times 51. I just want to make sure that I'm doing it right. Because it seems like the answer doesn't pan out to be. Okay, so 7, 8, 3, 5. That's 51, 25. Then 7 times 20. Hold on. 7 times 25 is 175. I did that, so it's negative. Okay. It is negative 20. Not quite sure. 8 times 3 is 24, right? 8 times 3 is 24. 7 times 5 is 35. I don't know. It doesn't seem like the answer is here. But anyway, let's so this is negative 11 y and negative 20. I don't see the answer here, and it cannot be no solution either. So it seems like there's either I'm making a mistake somewhere and I don't see it. Because there's yeah, I think everything should be 3 times 7, 21, 3 times 8, 24, right? 24. Yeah, that's negative 11. 3 times 51, 155. Yeah, I'm not quite sure what's going on. I don't see. They probably made a typo or something like that of that sort, because I got everything lined up properly. But anyway, let's move on. So, but you can see that the process is correct, is good. So y is equal to 20 over 11. I was a fiend. Okay. Now, let's solve for x. So it's going to be in fractional form. I don't know what's going on here, but anyway, it's going to be in fractional form. You take any of those two equations. So, for example, 3x plus 5 times 20 over 11 equal to 25. Wow, it bothers me that it doesn't line up, but the test generator sometimes makes some mistakes. I just want to make sure that, yeah, times 3, times 7, yeah, everything seems to be okay here. Not quite sure. Anyway, negative 7 times negative 35, right? 7 times 5 is 35. Yeah, it bothers me, but anyway, that they didn't get it right. Or maybe I'm doing something wrong, but I'm not seeing it. Okay, but sometimes there's typos. But anyway, let's move on. So 3x plus 100 over 11, right, equal to 25. Okay, so what we're going to do is just kind of multiply, get rid of the 11 here, the denominator. So multiply everything by 11, and we get 33x plus 100 equal to 25 times 11. That's 275. And then we get 33x equal to 175. And 175 divided by 33 is equal to 5.33. So basically it's going to be x equal to 175 over 33, or 175 divided by 3 is what? Yeah, it's a decimal number, so we leave it like this. I'm assuming that there's an error here. I don't see any error in my process, but if you do, please let me know. I don't think so. I think you know, there was probably a typo in the original system equation, but that's fine. Okay, so moving on. Let's do just one more, because the outcome is going to be different. Okay, so let's do the number 13 here. And so we have 3x minus 6y equal to negative 4. And then we have negative 9x plus 18y equal to negative 12. Okay, so let's see. So here you add vertically, nothing cancels out, right? Not the x term, not the y term. So let me find a multiple. So I could cross multiply this by 9 by 3, but I can also say, okay, well, 3 is a multiple of 9. So I can multiply the first equation by 3, so this becomes positive 9, right? So that's exactly what I'm going to do. So assuming that those are the x terms that I want to cancel out. So let's multiply across. I get 9x minus 18y equal to negative 12. Now at the bottom I get negative 9x plus 18y equal to negative 12. Beautiful. And then you realize there, when you want to add vertically, is that the x term and also the y term cancel out, and you get 0 here, right? 0 without the x and the y, because they cancel out, right? So 0 equal to, and here you got to be careful because these two are not opposite. They are the same. So when you add the two negative 12, it's really negative 24. This is where you need to pay attention, because here, this is it is not an equation anymore, because you do not have an x variable involved or y variable involved. Okay, it is a number 0 being equal to negative 24, and we know that 0 is never equal to negative 24, right? So this is a statement, and it's a false statement. So every time you come into the situation where the x variable and the y variable cancel out each other, yeah, they cancel out and it equates to 0. Whatever it has to be equal to has to be the same. Oh, well, if it's not the same, this is where I want to go. It's a false statement, and it leads to no solution as an answer. Okay? That's what happened. Okay? So here, also I want to caution you, do not write, when things are canceling out, do not write 0x, for example. No, don't write. Just put 0. They canceled out, so it's 0. Because 0 times x is 0, right? Right? Or do not put 0y, right? This is not, the y variable is not there anymore. 0 times y is 0. Don't forget, those variables represent numbers. So whatever that variable is, if it's multiplied by 0, it's just 0. Okay? So here, don't make the mistake of putting 0x or 0y and so on. No, you just put 0. Because I want to avoid, I don't want you to get confused. Okay, so it's 0 equal to negative 24. And that's a false statement, therefore it's no solution. You will have cases where you're going to have something like 0 equal to 0. And this is a true statement, right? And if you come to this scenario, then in this case, infinitely many solution will be your answer when you have a true statement. Okay? So that's that for systems of linear equation with two variables. Now, let's move on to graphing linear inequalities. Okay, so far we've graphed a linear equation, right? Last week we talked about, okay, well, I'm graphing a linear equation, right? Maybe I have my x-intercept, I have my y-intercept, right? I find these 2 points and my line goes through those 2 points, right? And that's it. That's my linear equation. Okay, but now we have a linear inequalities, right? And when we have inequalities, that means we have a series. So for example, if I say x is greater than 5, well, the x represent many values, right? It could be 6, it could be 8, 1 million. There's infinitely many numbers that are greater than 5. So it's kind of the same thing with this linear inequalities. Here we're saying that the expression x minus 3y, which is a linear equation, right, is greater than 6. Okay? So at some point here, if that's going to represent a line, but this is an area, right, either here, right, or there, that's going to represent this linear inequalities, right? There's an area that's going to be like, okay, well, in this area, x minus 3 y is greater or equal to 6, right? It could be this one or it could be this one, okay? And that's what we're going to determine. Okay, so let's get started with determine the area that's going to satisfy this linear inequality. Let me sip on my coffee here. All right, so what is the first thing to do? So the first thing we have to do here is to set the linear inequality as an equation. It's kind of odd, right? Okay. Yeah, I want to set this as an equation. So here, all I have to do is to write this as x minus 3y. Instead of having the inequality sign, I'm just going to put equal to 6. Okay? And now this equation, this linear equation, is called the boundary line. Is the boundary line. Okay? When we start graphing, you'll understand why it's the boundary line. Now, once we find the boundary line, we want to graph the boundary line. Okay? So we know how to graph this, and we can do that by using the x and the y-intercept, right? So the x-intercept is when y equal to 0, and we get x minus 3 times 0 equal to 6, which means that x equal to 6, which gives us the point 6, 0. That's my x-intercept. Okay? Now I do the same thing with the y-intercept, and that's when x equal to 0. And that's going to be 0 minus 3y equal to 6. And divide by -3, and I get y is equal to -2, right? So my y-intercept is 0, -2. That's my point. Okay? So now I can graph that. I can graph that, right? Because I have the 2 points and I know the line's going to go through those 2 points. Now, the boundary line, or the way it's going to look like in your graph, depends on the inequality sign. So the third step is the boundary line dashed or solid. And you're asking yourself, what is the difference between the two? Well, the dashed line means that, you know, part of the dashed part, so that's a dashed line, if you want, right? So the dashed part means that the line is not part of the solution. Okay, so all the points on the line is not part of the solution, right? And that happens when you have less than, come on, less than or greater than. There is no equal sign whatsoever, right? But if it's solid, right? If it's solid like this, then that means that your inequality sign has an equal sign. Okay? And in our case, we have an equal sign in our inequality sign. So, the solid line is going to be our answer. Okay? So, we're going to have a solid line that goes through the point 6, 0, and 0, negative 2. Okay? All right. So let's start graphing that. Let's put it here. So all right, so the exercise is at the 0, 6, oh, 6, 0, I'm sorry. So I can put 1, 2, 3, 4, 5, 6, right? That's my first point. And then the other one is what? The white cell is at 0, negative 2. So 0, negative, well, I mean negative 1, negative 2. And my other point is right here. So my line is going to go through those 2 points. So I'm going to do my best to put a straight line, right? That's it. That's my boundary line that goes through those 2 points. And it means that all the points on the line are part of the solution. Now, I need to find the region. We call that the region is the area in the graph that satisfy the inequality. Okay? And there's only 2 area, right? Because we have the boundary line. So we have area 1, right? And area 2. Right? You have 2 parts only. And that's the boundary line. So now we have to decide where's the region. So it's easy because all we have to do is take 1 point or 2 if you want to, right? So if let's say I want to make it very simple and I want to say that, okay, I just want to test the point 0, 0 into my inequality. So that's exactly what I'm going to do. Test the point 0, 0 and plugging it into my inequality, which is x minus 3y greater than or equal to 6, right? So x minus 3y is greater or equal to 6. Is it 6? Yeah. Right? So x is 0 and y equal to 0, right? So plug them in. 0 minus 3 times 0 must be greater or equal to 6. 0 minus 0 is 0, and is greater or equal to 6. Now, we have a statement here. And is the statement false or true? And the statement says that it is false, because 0 is not greater or equal to 6. So what does that mean? That means that the point 0, 0 does not satisfy my inequality. So therefore, this is not the region. Okay? And so if this is not the region, I can assume that my region is on the bottom part of the line. It's not going to be on top. That's all you have to do in this case, right? If you want to take another point just for the sake of it, let's say I'm using the point 0, negative 3, right? Let's use that just to check, just to be comfortable with the result. So here, test 0, negative 3. Okay, so I have x minus 3y is greater or equal to 6. X is 0, minus 3. The y is negative 3. And it should be greater or equal to 6. So here 0 is 0. Negative 3 times negative 3 is positive 9. And 9 is greater or equal to 6. And I can be confident that 9 is definitely greater or equal to 6. That's a true statement. Okay? So therefore, I'm confirming that the region, right, of this inequality, or the solution of this inequality, resides at the boundary line and everything at the bottom. And that's it. That's the way you do a linear, you graph a linear inequalities. Okay. All right. So let's stop. Let's stop right there. And if you have any questions, please send me an email. Feel free to send me a screenshot of the problem that you're struggling with, and I'll be glad to do a short video, a YouTube video, and send it to you. All right? Take care, guys.